Hello, Andre. This is Andrew Weitzer for the final game submission, and this is just the final rundown of all my code. Um, so yeah, I wasn't able to finish terminables and changing scenes, but I got everything else. Collaborables took a lot longer than expected, and documentation did take also a lot longer than expected. This is why this is coming on Saturday and some of Friday because I had to finish that up. But overall, I think that um, this was a good learning experience for me because it's the first system that I've ever implemented, and there's a lot of struggles understanding concepts, but I had a lot of people helping me and getting me to understand things, which is great. So right now I'm just gonna go through the basics here. I have a regular game uh, for the user that derives from GAM, and basically this is where you put all your scenes and create all your scenes and objects and collision stuff. So I have also call resources, create the scene, create your spaceship, create a cabin, and then set the collision for the spaceship and the cabin. For the load all resources, right here, basically just loads all the resources here, exterior ship, grid model, cabin, and then all the textures. Pretty basic. So I guess now we'll start with the scene. The scene. That's in managers. Scene manager. Start with the scene here. Scene starts with objects of all the different managers that it knows about, and it, when called, it will first of all it creates them, and then it sends it off to wherever it needs to go. When it an update scene sends all these, and then draw scene different. So and then the get functions right here returns a pointer or a reference to those objects. So let's see, from scene we'll start with the first. Oh, we'll do the input manager because that's like the first one we did. So input man and input man update. Alright, now the input manager. Alright, so input manager has a map of visible keys and key states representing those. Destructor clears a list, registers the key state, and if it's not already there, then it creates a new one. Deregister, and then update, iterates through those. Let's go key state then. Alright, key state. K is the key that it represents. Previous, current, and then the list of the list of key press, key release, and then the to delete list, key press delete, and then key release delete. And then registering for either one if it's pressed or released. Deregistering it, adds it to the press and delete list. Delete list, it deletes those lists if they're full, or if there's any thing in there. Update key just updates the current state of the key state, and then the define key state, just the boolean thing, all the different cases. Key pressed, and then just send back the callbacks right here. Alright, so that's the input manager. Let's do the asset manager right now. We'll come back to scene manager because that's like the first thing we did. Asset manager. Add model, add texture. This is from the low resources, so I want to tell sense. Alright, there you go. Add model, add texture, and then it's a singleton, obviously, so it keeps the instance and then says put this model in the memory, and then the get methods here. Going to the instance cortex is a singleton, so pretty good stuff there. Assets all loaded. Here's all the header files are nice and commented out and stuff. So yeah, nice little static or non-static method, private methods in the here that put everything in the maps right there. Alright, we're at scene. Let's go to update manager. Update manager. Here, alright, list of updatables. Clears it. Updates. Update all the updatables. Update all. Oh, no, this is to put it in the delete list, I think. No, this is a empty the delete list. Yeah, this is empty the delete list. And then this is to update updatables. Deregisters puts it in the delete list, and register obviously puts it in the active list. So just simple iterator stuff. Yep. Update manager. Yep. Okay. Alarm manager. Alright, alarm manager. Type def of just a type def iterator of a float an alarm maker for a multi-map. Instantiates the multi-map in the list. And same thing, just same thing with all managers. You use a delete list to delete anything that needs to be deleted before it updates. Basically, register. Pretty simple. Time. Get total time plus plus the amount of seconds that we set the timer for. Yeah. So plus this is the timer that the amount of seconds that we want timer to go off at, and then get total time plus that amount of seconds. So, and then we create an alarm marker with the time that we want it to go off at, the alarm ID, and then also this is like the which alarm, and then alarmable, which is the alarm it wants to send back to, and then put in the timeline, insert the pair of the time and the marker. Good stuff. Update alarms. Basically, just make if the delete list, yeah, this is just the deleted, I think. Yeah. Okay. Yeah, and then this is actually to set it off. So basically, if it's greater than 0, then it will go through and then set off the alarms if it gets to that. If the total time is greater than or equal to, it's first is the float, so the time here, then it will go off. Alright, alarm manager, collision manager. Alrighty. This is pretty simple. I didn't really put anything in here. I don't think there's any list that you need to instantiate here. No. Good. Yeah, okay. Yeah, because everything was in here. Okay. Yeah, so collision manager, select collision pair, and then if this is the same, they will insert in the group, and then the collidable groups add collision with self, so it basically just adds collision with itself. And then if it's separate, it'll do add test collision with other. So here. Yep, right here, and here's the collidable group. This is a rough one, collidable group. Gotta say. Have those things you gave us, those 2 things you gave us, the collidable collections and the collision text functions that you provide with us. Register, blah, blah. Yep. Collision test with self. If it, yeah, pretty self-explanatory. Collision test with another. This is the regular one, so it just iterates through the collidable collection, and then sets off the proper. First, it gets the result. So yeah, this is the main thing. If it's colliding with the object, mine and other, which is the 2 objects, then it will turn true, and then this will go off and it'll send the proper callback. Same with this one. So let's take a look at that. This one was really difficult. Let's go to compares. This one was rough. A lot of math here. Basically, just a lot of math to basically decide if the total radius, between the 2 objects. So if the radius if the addition of the two radiuses are less than the total distance between the two centers, then it's not colliding. And then if it's greater than, total radius is greater than the distance that's between the two centers, then it will return true. So basically, it's just a lot of math to decide what, or to find out what the two centers were, and to decide what the two radiuses were together. So that was fun. And just the bounding sphere stuff right here. Alright. Good, good, good. What else haven't shown yet? I haven't shown game object stuff. So, alarmables, updatables, inputables. But these are all, I think, self-explanatory. Just basically just sending, it's basically just the registering, being able to register to those certain objects. They're just basically, they're just the register things. Yeah. Pretty good stuff. What else I haven't done? Game objects themselves. I have some test game objects right here. I have the cabin and I have the spaceship here. Is there anything else I haven't gone through that is important? I don't think so. I think I got everything that I did. Obviously, I didn't do the terminals and changing scenes, but ran out of time. But and then so spaceship, basically just have register the instance for collision, so register that. Register inputables, so register the key events for certain events, so key pressed or key released. Register to be updatable, register to be drawable. This is a ship object, so graphics objects flat texture, and it combines the model of the ship, so asset manager get model ship, asset manager get texture ship texture, and then the collidable needs to set a model, so we set the model to spaceship get model. We need to get a world matrix, so the position, whatever position we want, the rotation matrix, which is 0, 0, 0, scale matrix, what we scale it to, and then we multiply it in a certain order, the scale first, rotation second, and then the translate. So I forgot, the graphics finally did something good for me, I guess. And then we set that to the world, and we also set the collidable to that, so because we need the bounding sphere, and also the speed and rotation. Update basically just updates its position, so basically just updates the world matrix and sets the world and the collidable again. Draw, render, and then also if I have a boolean, if it's colliding with the object, it will draw certain bounding spheres. So that's why I test if it's colliding or not. Key press, key release, basically just movement stuff, and then alarm stuff as well. So we'll test all those, making sure they're working, so you can see that. Okay, so now testing the. We'll test the. What I have here. So I have a spaceship, the bounding sphere above it, the cabin, and I can move it around. The camera moves around the spaceship, so the movement's fine. The input manager is working. And then once I collide with it, good stuff. There we go. Alright, and I think from the previous sprints that you saw that my and obviously the update's working as well because it's updating the position of the ship, and the alarms you saw from last sprint, they're working good, working well, and yeah, collisions are. And then you saw that it was colliding. It got the colliding callback because this was true, obviously, and which would make the bounding sphere work. The draws are working, obviously, because there's some. And then yeah, so let's look at my UML. It's not as fleshed out as I would like to be because I didn't have a lot of time to do it, but I did the best I could with the time I was given. Not the time I was given, but the time I had left. Let's say that because it was like maybe like